staying on Desmos graphing calculator here, I want to answer this one. How many real solutions does the equation have? Not what are the solutions, how many, okay? So I'm going to just delete that equation out. Let's put the equation for number 20 here. Y equals 2x. Remember to do the exponents. Shift 6, number 2. Right arrow to come out of the exponent, minus 3x plus 5. Okay, and there's my graph. In fact, for your work, let's just draw a little sketch of that. Now, when I say the word sketch, I want you to go, oh, just an idea, just a general shape, right? Something like that would be just fine. Do you notice how I didn't plot points or anything? I just wanted the general shape of the graph. So how many solutions? So what this is asking for is when you look at the graph, how many x-intercepts are there? That's really what this question is asking. I don't see any x-intercepts. This graph does not touch the x-axis in any way, shape, or form. That means there are none. There are no real solutions for this problem. Okay? Make sure you have these two things in your notes, though, so you'll know what you're looking for. All right. Sounds great. Let's go ahead and take a look next at problem 21. So we were being given equations for the attendance of pool A and pool B, and we want to know on what days these two pools have the same attendance. Again, I'm going back to Desmos. So let's switch back. I'm going to clear out the equation from our previous problem, and I'm going to type in equation A, y equals 20x plus 124. Press enter, and then I'm going to type in the equation for pool B. There we go. Now, I am looking for an intersection here, but I don't see it. You'll need to use these arrows over here to zoom out until you can see that intersection. Ooh, it looks like it's pretty close. Now, friends, I am dragging this down just by holding my cursor. Then I'm going to zoom in a little bit because I can see it. Right? I'm looking where those purple and the green intersect. Now, the good thing about Desmos is it will find that intersection for me. It's a beautiful place here. Ah, there it is right there. When I clicked on them, did you notice that Desmos told me, hey, there's a dot here. It's important. So, friends, let's figure out which day was the attendance the same. Was the day 4 or was the day 204? And then it says, what was the attendance? Was the attendance 4 or was the attendance 204? Use some common sense here. So the attendance was 204 people at both pools on day 4. Now, remember, Desmos is your friend and is going to do a lot of the heavy lifting here, but you've got to know to zoom out, to drag it till you see that intersection. All of those good things are for you so that you can use Desmos properly. All right, let's look at problem 22. We're looking for the solutions again here. So I'm going to stay on Desmos and let me clear out a little bit. I'm going to zoom back in and I want to get back over here. Come back. There we are. There's my y-axis. Oh, and let's just use that home. That's so much nicer, isn't it? We'll just click that home button. Okay, let's put these equations in. I've got x to the second, come down out of the exponent minus x minus 2, and press enter. And then I've got negative x plus 2. And I'm looking for the intersections here. Now, just for my work part, I'm going to draw a sketch. Remember, sketch means general shape, right? So I've got this parabola and I've got this line And I'm looking for, and I didn't draw my line really good, but that's okay. I'm looking for these two intersection points. And friends, Desmos did all that work for me. I've got negative 2, 4, and I've got 2, 0. That's where those two intersect. Those are my solutions.
Okay, friends, in this problem, I'm going to solve for the solution of the system using the substitution method. You can see that both of my equations are set equal to y. So I'm going to take this 3x plus 5. I'm going to substitute it in place of this y in the first equation. So that will give me 3x plus 5 equals x squared plus 4x plus 3. Now I want to get all of the terms on one side of the equation. So I'm going to subtract 3x from both sides of the equation. You'll notice I lined it up with the 4x. Then I'm going to subtract 5 from both sides of the equation. And that will give me 0 over here on the left equals x squared. 4x minus 3x is 1x. And plus 3 minus 5 is minus 2. Now, friends, we want to factor this on the left side into two parentheses. Because of the x squared here, we'll get an x and an x in our parentheses. And now we're asking ourselves what? Two numbers multiply to give me negative 2, but add to give me positive 1. So that's going to be negative 2, positive 1. Now, if we set both of those parentheses equal to 0, x minus 2 equals 0, and x plus 1 equals 0, we'll get that x equals 2 and x equals negative 1. Now that is only half of our solution. You see, we have 2 and something and negative 1 and something. We need to figure out what those are. So let's take that second equation because it looks easier, y equals 3x plus 5, and now we'll substitute in the values for x. So I've got 2 as my first one. 3 times 2 gives me 6. 6 plus 5 gives me 11. So we know the point is 2, 11. Let's do the same for negative 1. We'll substitute in negative 1 for x. 3 times negative 1 gives me negative 3 plus 5 gives me 2. And so my other point is negative 1, 2. So we have two solutions for this system, 2, 11 and negative 1, 2.
We're asked to simplify. So I want you to think of these radicals and remember that we are trying to look for perfect squares. So think about your perfect squares. They're 1, 4, 9, 16, 25, 36, 49, 64. And then you could also do 81 and 100. I'll list them all out through 10, okay? Do any of these divide into 128? Well, 4 does, okay? And 16 does. 36 does not. I'm doing only the even ones because 128 is even, by the way. 64 does. Okay, so I want you to think that I could rewrite 128 is 64 times 2. Now, 64 times 2 is 128, but the square root of 64 is 8. But I got to leave the 2 under there because the 2 doesn't have anything to come out with. If you want to check these, you can go to Desmos, and I'm just going to use it as a calculator here. Let's do my square root. You know how to notice how I did that, friends. I did SQRT, turned it into a square root, and I put the 128. It's going to give me a decimal. Hit enter. Then I'm going to do 8 times square root 2. And I'm going to make sure those come out to be the same decimals. If they do, I know I've simplified it. So use that tool as your best friend. We've got one more to go here on this page. So notice I've got 6 square roots of 2 minus 1 square root of 2. Let me say that again. I've got 6 square roots of 2 minus 1 square root of 2. That means I've got 5 square roots of 2. Think about how I did that subtraction there. 6 square roots of 2 minus 1 square root of 2. So I hope that helps with this page of the practice exam. If you